Hello, everyone. Can you hear me?
Yes.
Thank you. Good evening to all of you. So today we are going to learn about multiple regression analysis. This is the module number 3. So before starting this, let me give you basic concept about regression so that you can understand the context. And then we will learn about the different technical aspects. So I'm just going to start the whiteboard. And hope you can see my whiteboard. Okay. So this is the regression, multiple regression. Let me start with simple regression. So this is multiple regression. Let's say you plot a simple 2-dimension. This is Y, this is X. And let's say this is your income. Let's say this is your spending. Okay. So this is your 2-dimension graph. And I plot over, when your income increases, what is the spending behavior? So let's say when you have even, zero income, this is 0. When you have 0 income, even then you have some spending because certainly some bills has to be paid. So, but as your income goes on, your spending also goes on. So this is a simple graph that I plotted. Now let me do. So what is the equation of this graph? Spending equal to, I'm just writing A plus B X. X is your income, or sorry, spending equal to B into income. Instead of X, I write here income. Or how can eraser. So B and income. Now question is this: you have spending, you have income. What is A and B? So let me give you. This is this distance, or this is called intercept, or this is called A. So whatever is this intercept, this is what is B? B is called slope. So how do you get the slope? You put 2 points on at any place on the line and draw perpendicular and horizontal lines. So let's say let's say I draw this. So this difference is del by, so slope equal to B equal to difference in Y divided by difference in X. So this is B. So you can get this and this. Now when you have the equation, when you have A value, when you have B value, and suppose you want to, what would be your spending when your income would be? So once you make the model and you can predict based on your income what would be the spending. So this is a very simple concept of simple regression, because one dependent variable is spending, and here independent variable is income. Very simple. Now let's move further. So the second step, we want to see whether these constants, this is intercept, this is slope, are these useful in predicting your spending or not. So basically we test this is useful or useless. So this and this, most important thing. If suppose this is useless, means whatever is your income spending will be same. Useless means these are zero, means whatever your income spending will be. So now let's say how this line is drawn. The line is created based on the number of. So I'm just going to erase this part. And okay, let me make here. So let's say this line is right here. And this line is created based on different observations. So these are, let's say, hope you can see, these are different observation, and this line is called best fit line. What is called best fit? That means this line is best fit from all these observations. This is individual observation, this is individual, means these are the different observations. So the difference from here to here, or difference from here to here, or difference from here, these are called errors. Are you getting me? So all these points, so in regression, this also has value, because we would like to check whether these errors are normally distributed or not. They are, different properties of these error. Basically, they should not be abnormal or different aspect we will cover later. So we want to check also these errors related to that in order to validate model, because we want to see whether this line is perfectly fit, or it's a it is really best fit in this. Yeah, error is same as residual. Oh, yes. So I'm using my old terminology. Thank you, Brandon. Now look into the third thing. So this is a simple regression model that we learned in the previous class. Now we are going to learn multiple regression. So because we can see only 2 dimensions on this, let's say y equal to, or spending equal to, A plus B income plus C, let's say inflation plus D, different factors. So multiple regression means you have multiple independent variables. So this is the clear difference between simple regression and multiple regression. That means you have multiple regression. Okay. Now let me talk about little bit about our discussion, because some of you have that. So let me start and go over. Okay, you can see this is discussion. As you can see, every day this number is changing, and when I created this, so this is very interesting. And you can see this is the percent of employee, 8% of 9%, 15%, 10%, 8%. So basically 32%. So different, percent of employees are laid off in tech industry. This is basically tech companies, 425 tech companies with layoff. And every day you will see the new data is coming here. Today to San Francisco and Los Angeles based companies, fine. List of laid off companies. So if I go here and I hope you can see my screen. So here you can say their email, everything is right here. Means full details they are sharing, they are not sharing based on. So this is very interesting, because we are all working in the tech related job and tech. This is a chart based, it started from last year and now this year in last month and this month. So basically lot of laid off. Now our, the discussion is based on this only. What is so what percent of laid off depends on different variables. So here, let me start again on whiteboard and explain to you. So let me clear all. So basically, this is laid off is taking place across the world in particularly tech companies. There could be many reasons. So basically, let's say I'm just assuming, and you, based on your understanding, you can say laid off there are many variables which are, so this is a, let's say, laid off, and it is due to recession, economic reasons, due to automation, or due to AI, or due to, let's say, third reason, I'm just laid off, economic, AI, due to some other reasons, let's say slowdown, or inflation. You just, from your understanding, you create your own model. So this, let's say this is a laid off. And practically, when you go and do any research in your field, how to do, this is the starting point and how to, so you laid off here. Now I understand these are the three reasons of laying off. Okay. So what would be the model? Laid off equal to A. So first you need to, based on your understanding, your research, what could be the reason in your industry for laying off the people, and because I think it is happening everywhere. So A plus B, automation and AI. So I just put AI because lot of work, lot of routine processes, lot of regular processes are automated with the help of AI and different technology solutions. So that is the biggest. There is only a specialized job need people. Plus, and like Amazon is putting a lot of robots for their warehouse management or warehouse instead of manpower. So and robots are working 24/7. They are more cost effective. You don't need to pay for insurance and healthcare and many other things. So this could be the reason. Second is B and C. C and what should be, let's say, economic or recession or eco, plus D and inflation. Okay, now we got our model. Now, how to prove this model? First, you need to discuss why you are choosing these factors and what are the reasons. So now you want to run the test, you want to run the model. How you do? So the third step in this, once you make the model, third step to collect the data. How do we collect? So let me explain to you. So let's say you create a questionnaire. Normally in real world, it happens. So basically you go and ask 10, 12 of your minimum friends. Let's say you are asking, I'm asking to Mandy. So basically, what percent of laid off is possible in, what percent of laid off possible in your industry? So let's say somebody says 5%. Okay, this is my dependent variable number. What do you think, what do you think automation and AI is causing laid off. So basically, if you ask this question to, on 1 to, 1 is least, 2, 3, 4, 5, 6, 7. So this is least, this is a most. You can give a degree based on that. And somebody is saying 6. The similarly, instead of economic activities, economic slowdown is causing laid off. Sorry, I'm not writing full sentence, but you understand, it's causing laid off. And again, 1 to 7 point, 1, 2, 3, 4, 5, 6, 7. Somebody is saying 5. The third, what I said, inflation. Inflation is causing laid off. So on 1 to 7 point scale, somebody is saying 1, 2, 3, 4, 5, and 6. So somebody is saying, okay, I believe, it's 4 on 7 point scale. Now, let me show you. I think I have to go back on seed. So just a minute. Share. Okay. I hope you can see my mini tab. Can you see my mini tab? So laid off percentage. Laid off percentage, laid off. Second thing, what is the automation? AI and AI. Third is economic. Fourth is, what is the fourth? Inflation. So these are the 4. So let's say laid off is 5%. So I put here 5. AI, and this is 6. This is 5. This is 4. So I got this response from myself. Let's say I ask Mandy. Mandy is giving 7%, 4%, 4 out of 7 scale, 6, 3. Let's say I'm asking Jamie. Jamie is giving another answer, 8%, 7, 5, 6. Let's say I'm asking to Brandon. Brandon is giving 9, 2, 6, 4. And, so on and so forth. You can keep going. As you learned from previous class, that higher the sample size is better the result. So this is 4 people response. You can go for a couple of more. And then you run the regression model, and then you can see whether AI is really causing causing in laid off. Economic is also causing in laid off, or inflation is causing in laid off. So basically, this is based on opinion. You go and take the opinion, and based on that, for example, I'm just sharing my own research, how I did. So basically, this is my research. Role of emerging technologies, accounting information system. And this is how. So actually published in one of the top journals. So here, so basically this is how I made the model. And these are different hypotheses. Now, based on that, I got these numbers. These numbers, this is nothing but a slope. 0.255 is nothing but a slope. What is R square? Here somewhere you can see the R square. So this is how these are the slopes, and variance inflation factor. And here you can see the R square. This is R square. And these are the betas. So we can prove in industry based on the opinion. Now let's go back to, now I hope you understand the concept, you understand everything. Now we are going on the basic technological or terminology or basic concept, technical concept in the chapter. So basically this is based on chapter number 12 and 13. The regression, you can find, when you go under this statistics regression, and you can find the correlation also here. In basic statistics, you will find the correlation. Another way is to do using this option, alternative way using Minitab. So here we have, so when you go here, assistant, and you have under assistant, you have the regression. And this option comes right here. When you see simple regression, you go for fit model only. So now you choose this one. So this option is directly here. Correlation and hypothesis testing. So basically you learn what is the relationship between variables. So there's a difference between correlation and regression. In simple regression and simple correlation. Simple, so where is my white? So R, small r is correlation coefficient. Small r is equal to correlation, and capital R square is regression. So in simple regression, R correlation multiplied with correlation, you get the regression coefficient. You get the regression R square, but not in multiple regression. So first thing to check the relationship among many multiple variables. So I'm just going to take the, so let's say I just took this. Oh, this is last time, I believe. So like this is the model I was discussing in the last class. So chance of admission in any university depends on GPA of the student, depend of letter or recommendation, statement of purpose, university rating, GRE score, and TOEFL score. So let me run this regression, fit regression. But before running, I have to check the correlation among them. So what I do, I go under statistics, basic, and I can do the correlation. So what I need to do, I just do here, I select all of them. And here I have different option, store correlation matrix, graphs. I can see the graphs, and results must be pairwise correlation table. When you just check the, now you can get the results. So basically we can't, I can't, by my naked eyes, I can't understand much here. So what I can understand here, I can understand which is the high correlation. So from this pair, which is the highest correlation? Highest, I can say 827.827, 82. So correlation from -1 to +1. So this is, I believe, highest. P-value is the most important thing, which says your correlation is useful or useless. Correlation is useful or useless. Why? Because you can see this. Just a minute. So rho equal to all entire population correlation. Alternative, it's a not 0. So equal to 0, and when it will be null hypothesis says equal to 0, and it says not equal to 0. Equal to 0 means there's no relationship, 0 relationship, no relationship. And alternative says this. Calculate R p values and you can say, so I'm just going to show which correlation here you say is 0 and which is not 0. Can you get it here? Oh. Again going. Do you see which is useless or which is useful here? These are the pair of all the variables. So SOP inversity rating. What is your understanding from this analysis?
They're all useful.
They are all useful because their p-value is less than 5%. Here, this is a p-value which is almost 0. Therefore, if it would be more than 7-8% or something, then it is more than alpha value. Then they are all null hypothesis proven. Then useless or 0. But since this is all, means all useful. Now, first step we have done to check the correlation, and then we go for regression. So this is another way to check correlation by graph. Also, you can see, you can put a graph, 2-dimension graph, where you can go on a scatter plot, but you can see two together only. So I would like to show you that. And let me. So here we go, graph, scatter plot. And let's say you can go here. And you can say bivariable, chance of admission, and let's say GPA. So I can plot two, in pair. So just I'm going to show you one. So here you can see the chance of admission, and this, it looks, if you want to see one by one, you can look into this way. So basically I can see here, I can draw a good line here. This is a good relationship. So, okay, so this is another way. Now, third step is to check the correlation. So I already explained what is the meaning, p-value. Then now simple regression, I don't think you need to learn because already we covered. Now we go to multiple regression. So these are the notations I already explained, intercept, and this is the slope. So this is residual or error, like whatever you learned very first time you remember. So, I learned in the way, this is an error or residual, this difference, which is like this. Now, so now we go to the direct multiple regression. So go into regression. We are just going to learn here fit regression model. There are many other regression model, they depend on different situations, but we are just learning simple fit regression, multiple regression model. Here you just, so when do we assume the normality? If you learn more than 30 simple samples large enough, n equal to 10 multiplied by k. So basically learn these things. Now eyeball test you can do by scatter plot, whether there can be any line or not. So just go here, we did. Now I'm just going to show you same thing. Now I run a regression model. Second step, regression, fit regression model. And so chance of admission, I just take all of them as independent variable. However, I can take here categorical predictor also. Categorical means inversity and research. Here you can see research and not research. These are two categories. I can divide into that. So basically I can just go here from here to here in this, and I can go research and not research here. Now we have different option here. I'm just going to see the graph option here. Second thing, results. Here, different options are there. I'm going to check Darwin-Watson also. Darwin-Watson is useful in time series. Storage. So basically what is important for me here, residual, because later on I can check whether it's a different test we can see. So I'm just going to check residual, which can be stored. And okay, now I'm going to do this. Okay, now let me remove this. So now we can see. I hope you can see. So since we put two categorical variables, research 0 and 1, so two equations are created, one for non-research university, which is 0, one for research university, which is 1. So which kind of? So basically this is the model. If you are opting for chance of admission in research university, you use the first equation. If you are going for research university, use the second one. So when you put a categorical, it create multiple models based on different categories. Now I have, so even same thing will happen with this. So here we go. This is intercept. You can clearly see intercept is very first value, which is a const. So this is intercept. This is a GRE, or let me, for simplicity, let me make a very simple one model, and instead of that, so that it can be easy for all of us to understand. So I just remove research here. I just remove research from here, and I just do all from chance. Okay, I got it. And I think something is wrong. So I'm just going to, okay, so statistics, regression, fit regression model. And let me do, so chance of admission depends on GRE to research. Okay. And I think all the options are clicked. Okay, so now we got, the combined model. So let's see. So this is intercept. This is another slope, which is with reference to GRE. This is second slope. This is third. This is fourth. This is fifth. This is sixth, 7. So 7 independent. So chance of admission depends on these many independent variables. Okay, so we got the, now first thing, which is useful and which is useless. So let me see which is useful, which is useless. Now here, null hypothesis. What is the null hypothesis? Since you already expert into this, what is null hypothesis? Null hypothesis says constants are, slope or intercepts are, I'm just directly saying constants are 0. H0. H1, constants are not equal to 0. Now you tell me which constant is 0, which is not, which is useful. So basically this can be useless in other simple word. And this you can say this is useful. Now you tell me which constant, which variable or which independent variable is useless in our model.
Would that be university rating and SOP?
Perfect. So because here this value is coming. So p value is our 5%. By default, it is coming. This is coming 72%. This is coming close to 12%. So this is greater than in both the cases, this useless concept means in this model, if you use, if you don't, let's say, if you don't submit your statement of purpose and you don't decide university rating, it does not matter. It will not make very significant chance of admission difference. Let's say you forget 2 items in your application. It doesn't matter. But rest of the items are matters. So sometimes if you forget to write a statement of purpose for admission, okay, that's fine. It will not make much difference. So university. So in this model, university rating and this chance of research doesn't matter. Means if you can keep this 0 useless, rest 5 variables are useful. So first thing we got it. So p-value is standard error, coefficient, p-value, variance inflation factor. I'm coming over there just a minute. So now here you can see the S, standardized error. This is R square. R square, what is the meaning of R square? R square is saying these 7 variables, how many 7 variables are there? Together, 82.19% change in chance of admission depends on these 7 variables. 82.19% means 82% chance of admission depends on these 7 variables. Rest, what about 18%? Maybe different other aspect which is not researched or maybe something else. So basically this model explained 82% chance of admission due to these variables: GRE, TOEFL, university rating, statement of purpose, letter of recommendation, CGPA, and research. So 82% chance of admission is explained due to these 7. So this is a way. Okay, what variable do you use to determine significance if you don't have the p-value? P-value is usually there, yeah, the critical value is another way, Jamie. Critical value is another one. Because usually probability, this p-value is probability value, other is critical value. This f value is, they have the critical value. So the second thing is that, let me remove this. So now you see here, how you check the regression is useful or not. So here you can see f value. This is the f value and this is a p value. So, regression, total regression, R square, where is R square? 82%, this is useful or significance. Again, here you can get this answer. So for R square, why we are using R square f value? I think I explained in the last class, because up to 2 variables, it is t-test, after ANOVA is, ANOVA used f value or f distribution. So p-value is probability. Again, I mean, we learn this to check the critical value, but after module 4 or 5 in the last course, we started going directly on p-value, because this is directly, most of the software gives p-value. So F value is 324 and P value is this. So again, R square, null hypothesis says R square is useless. And H1, R square, useful. So what you say, this regression is useful or useless? Certainly it's useful because you can see the p-value is this much. So again, you can see these which constant is useful. So here, you can understand this. I'm coming over this. You can see what is the relationship between these two numbers. Here you can calculate these numbers based on, let's say this, t value and this value equal to this value. So this multiplied by this. So I'm just going to show you how to calculate. Where is calculator? Can you see my calculator here? 12.23 into, I hope you can see my calculator, into 0.104. And you can see, I mean, I did not put negative side, 1.726. 726. So 19. So basically, same thing, if you have two numbers given, you can calculate the third. So similarly, t value here, this multiplied by standard error of coefficient, this is a coefficient. So this is the relationship among these. So you can simply calculate if something is missing and two numbers are given, you can calculate. If I ask in exam, coefficient is this value, standard error of coefficient is this value, what would be the t value? So you can simply do the arithmetic and you can find the t value. Now come to the third. So this is the third R square. This is the R square adjusted. What is R square adjusted? R square adjusted is, when you remove all the unusual observation, unusual and like, when you remove all unusual things from the model, this is adjusted, which is always less than the R square value. So R square is 82.19. This is always less, which is 81.9. So basically, if you see which is not useful in our model, SOP and research is not useful in our model. If you remove these two things and if you remove other things, it can be R square. And this is, more refined R square. So we are not, talking about that. And basically R square and R square adjusted are useful. Analysis of variance. Now look into this. Fits and unusual observation means model made the fit model, but they model out of 500 observations, they understand these numbers. These numbers are observation number 10, 11, 41, 43, so on and so forth. I don't know, about 20, 30 observations are unusual, means there could be error, there could be a mistake from data collection. So there are two ways to do that. One is you remove these from the model. Second thing, you go and check with the people, those who have given the data, whether this is correct, or clean this part in order to get better results. So these are coming out of. So this is, you can see, you can observe yourself, okay, number 10 observation is not good, is not, adjusted with the model, or this is unusual. So this is the model up to here. And now after that, normality plot. So this is the first thing to check the model. So this is the model, which is useful predictor, which is not useful predictor. You can clearly understand. Is it clear so far? Now, if it is clear, the next thing, whether the residual are normally distributed or not. So again, here we have the, so what we have done here, we have residual, when we run the regression model, we put the option to have the residual stored in. So this is the store. We put the residual to store in the separate column. So this is stored. Now I'm going to check whether this is normally distributed or not. I go under graph, where's graph, and we have a probability plot here. Can you see the probability? I just put the single one, okay, and I take the residual by default here. This is the residual. I don't do anything here. Just do the okay. And here we go. And clearly from the graph, let me make a small. Okay, so here you can see. Again, you tell me whether this is normally distributed or not distributed. P-value is here. Everything is right here. What do you think? It's normally distributed or not? Error or residuals are normally distributed or not distributed?
Yes.
P-value is less than. Okay, let me go then on that. So this is p-value is less than 5%. P-value is less than. So here I have a slide to explain. Hopefully you can. Oh, sorry, this is not the one. So H null hypothesis says error are normally distributed. Alternative says error are not normally distributed. And that can be done by normality plot. So now you have the null hypothesis means alpha value should be, or p value should be greater than alpha, which is more than 5%. Alternative says less than 5%. Here, what we get here. Now you think.
Well, it's less than 5%, so not normally distributed.
Yes, that's correct. So first thing, errors or these residuals are not normally distributed. First thing. So after validating our predictor, we are just validating our other things. The errors are not normally distributed. So I think where we did standards. So here you can see Minitab outcome, regression. So standardized residual versus fit, this is another thing. If you keep the option here, statistics, regression, and fit regression model. And here in standardized residual versus, so here fit, these are the, you can keep these options and they will be stored, but I'm not doing because I have other way to check it. So let me show you. So first thing, regression, where's yeah, so non-constant variation, or which is called heteroscedasticity. I mean, I'm not able to pronounce correctly, but you can understand what is the meaning of this word. Errors have constant variation, means there is a variation in the constant. And alternative says error have non-constant variation, means constant variation can be visually tested by a scatter plot of the residual against each predictor. There will be no pattern violation of constant variation assumptions is, so basically errors have constant variation, means it will not have funnel in or funnel out kind of thing. So if you have funnel in and funnel out, this is called non-constant variation, means error are, if you see equally, then I just check here in my, so whether we can check whether this is a errors are constantly distributed or not. So where is that? So okay, here we go. And I just use the assistant because it's a simple. I go under regression, I go under multiple regression. Response variable is chance of admission. Continuous variable are GRE to research. I select all of them. Okay, I selected. Okay, categorical here you can also do. I'm not doing, I'm just doing directly. Oh, too many, what it says. So GRE. Okay, let me select. Okay, now I do it. Minimum number of columns 1, maximum, so it can only take 5 maximum columns. So I'm just removing 2 useless items. So I'm just going to do GRE, TOEFL, university rating. A statement of purpose is not important for us, so I just did 5 because it can take up to 5. Now here we get all the numbers, everything. So here you can see. Now I am interested in one thing, which is funnel in and funnel residual versus fit. So can you see? Okay, here we have let me make it smaller. Okay, here we have, so constant variation or not constant variation. So I'm just going to show you. Basically, I can see this is, like this is like this. Basically, I can see unequal variance. I can see the residual have unequal variance because I don't see, constant thing. So basically, based on that, you can predict whether how the pattern is looking. So this is the one which explains. So funnel in or funnel out is non-constant variation, and otherwise it's constant variation. So basically, you have to see the pattern and you can see normality. Now another thing we are going to see, multicollinearity. What is multicollinearity? So let's say, okay, this is, for example, this is our model. Yeah. Multicollinearity, where is the correlation? So this is a correlation. If 2 or more variables are, highly correlated, means they are showing exactly same behavior, then what is the value of having them? Let's say, 2 exact same predictor, their behavior, their correlation is almost same, a very high correlation like 9.99. Then they will say so exact same behavior. In your project team, if you are recruiting 2 exactly similar skills of people, then they will do the same work. Similarly, here in model, 2 variables, they have exactly same behavior. That is called multicollinearity, means it is creating an issue. What is the need of having similar kind of predictor? So that is explained by VIF factor. So here, you can see if predictor, basically VIF is 0, 1. Can you see here? VIF is 1 means no variance inflation. If 2, it's a mild variance inflation. If it's strong, it's a 10, and 100 is severe. Are you getting me? So anything in research and practically, it's about up to 5, 6 we can consider, 10 and about 10. It's a severe situation. Therefore, we don't consider. Now look into our model. Where's Minitab? To be, where's, okay, right here. Now you see the VIF. What do you see?
No, we see your mini tab.
Oh, sorry. You don't see the Minitab? Oh, just a minute.
We do see mini tab.
Yeah, so here you can see the VIF.
Well, the values are less than 5.
All values are less than 5. That means what we can say means no way, it is mild, it is like moderate kind of variance, but it is not strong or severe. So up to 5, 6, we can consider in real practical life on all the research that you see. 5, 6, they can consider, but not beyond 10. So it is very ideal if you have VIF1. Like, our research which we did was, this is the research, hope you can see this. VIF is 1, close to 100%, which is close to 1 in our cases, what we did. So now what we did, multicollinearity. So 10 says 9. So I think regression, this is the errors are normally distributed. Errors have constant variation. Third is errors are independent. Means whatever residual or errors you are getting, they are independent. So we check this assumption, we check this assumption, now check the third assumption, and that is errors are non-autocorrelated, errors are autocorrelated. And we can check that based on autocorrelation, which is Darwin-Watson test. And it says if Darwin-Watson is less than 2 suggests positive autocorrelation, more than 2 suggests negative autocorrelation. So here, based on that, we can say we will use observe, this is like error or residual for evidence. And Darwin-Watson can be 0 and 4, 0 to 4. H0 to true, no autocorrelation if Darwin statistics will near 2. So this is the third thing. And so let's see what is the Darwin-Watson in our case. Did I record the Darwin-Watson here? Yeah, here. This is DW statistics, which is 0.795, which is less than 2. Then what we can say here, positive autocorrelation. When this, usually in this kind of data, cross-sectional data, DW is not important, but in time series data, Darwin-Watson test is useful. Reason is that because, autocorrelated, non-autocorrelated, correlated. So that violates, so this problem is in time series data, not in cross-sectional. So basically, whenever you do time series data, always check the autocorrelated results is biased. So basically, this is the concept of. So now question comes, how many observations do we need to have to do the regression analysis? And actually, this is explained here. I just made a slide. And so yeah, this is the rule. So Evans rules, these many observations has to be there in order to run a regression model. Limit the number of predictor based on sample size. When n upon k is small, the R square no longer gives a reliable indication of the fit. So this is Evans rule, n upon k greater than 0. at least 10 observations per predictor, means per predictor must have 10 observations. And this book author says 5 observations. So minimum 10, but if you really want a good model, minimum 30. So this is about regression model, and now you are free to ask question. This is what I wanted to explain today. Any question, please, you are free to ask. Yeah, it is Evans rule. Where is Evans rule? Yeah. So at least 10 observations per predictor. You simply understand at least 10 observation per predictor. Yeah, this should be 10. Yeah, this should be 10. Yes. Sorry, this is this issue of, so I can make it. Sorry. Thank you. Thank you, Jamie. Any other questions? So this is fine. Yeah, this is. Any other question? If you don't have, I would like to say a wonderful night. I hope you understand what I expect from you in discussion.
Yeah, I have a quick question about that. So are we expected to collect the data for our discussion post?
Yeah, so basically, first you can make your model. Basically, first thing, you just find the predictor of layoff. What are the causes of layoff? You write about that. In case if you get 10 people, just chat with your friend, colleague, or someone. What do you think? And based on their opinion, you can collect 10 observations. Or if problem, okay, you can do 5. You yourself count your 1. You are the expert, so you can count yourself 1. You can talk. We have a class, and I think 240 students in the class, and we can chat. We can chat with each other. We can talk, and by this time, I think you have some friends in the class.
Okay, great. Thank you.
You're welcome.
Question 12 in the fill in the blank,
Yeah,
comparing two
I think
variables.
if you have question related to fill in the blank, you can ask individually. I will reply to you email, because it gets recorded, and so you just send me an email. I will reply to you just immediately in 5 minutes. If any question related to the concept and this, I will be happy to tell, because I get some emails that you said this thing. I give the hint, but it creates some other issues. So I will reply you in 5 to 10 minutes. Don't worry if you send me. Okay, any other question related to this lecture or concept, or if you don't understand anything, feel free to ask. If you don't have, I would like to say have a wonderful evening. Good night, and we will see each other next week about same time. Thank you. Yeah, so please send email. I'm going to reply you. Okay, bye-bye. Good night.
Thank you.
Yeah.